Here we are looking at a word problem that asks for instantaneous rate of change. So we want to remember that even though these word problems can be overwhelming in calculus, we really have two options that we discuss that could be formulas, and there's always, with word problems, you could just be plugging into the function that you're given. So let's just write up top here. For word problems, we really have three options. One, you could just be plugging into the original. You could plug into the original / given function. Always a possibility where they say, here this function models the amount of money in your bank account given the year, and then it says plug in 2004. Okay, so you just plug into the original. Another option could be average rate of change. You want to remember average change or velocity, average rate of change is just a fancy word for slope. So the phrase average rate of change between 2010 and 2024 would just be finding the slope formula between those 2 years. We do our f of b minus f of a over b minus a. Takes some time to plug into, but it's not too overwhelming. There's our second option. If it asks for average change, use the slope formula. Last thing, if it just asks for change at an instant. So we read a problem and it says, how fast is it changing in 2026? So we make that prediction about a certain instant, would just be plugging in to the derivative. Take the derivative and plug in minute 14 or year 6 or something like that. So as we read this word problem, I'm going to narrow it down in my mind. Am I just asked to plug into the function that I was given? Does it say average change where I want to plug into the slope formula? Or does it ask about change at an instant where I'm going to take the derivative and then plug in? So looking at this problem, we have the number of people newly infected with a virus on day T. So we have some units here. So the day is T of an epidemic is given by this N of T. So you plug in days and you get out the number of people infected. So I'm going to write that off to the side. My input is days. My output is number of people infected. So plug in days, how long has this epidemic been happening? Then we can say how many people are coming down with this virus. It says find the instantaneous rate of change on day 4 and compare that answer to the instantaneous rate of change on day 9. So if we just plug into the original function, we're not asked about any sort of change, that would tell us the number of people getting sick. But it doesn't ask that. It says find the instantaneous rate of change given the certain day. So we're going to take the derivative of the function to find how fast the people being infected is changing. So we're going to take the derivative because I see the word instant. Instantaneous rate of change means derivative. That's how I'm making this decision here. So the derivative of n is going to be labeled n prime. We're going to bring down the power. 12 times 2 is going to give us 24. So we're going to have 24t minus, bring down that power, we'll have minus 3t squared. And that will tell us how fast the epidemic is spreading for any day. And this asks about day 4 and day 9. So we are going to plug in n prime of 4 and n prime of 9. Because it asks us the days, and we know when we plug in days, and we get out the number of people infected. So I'm going to grab my calculator. I'm going to replace these t's with 4's in parentheses. So just like this, 24 times 4 minus 3 times 4 squared. And we're going to get 48. And then if we do the same thing but plug in 9, 24 times 9 minus 3, parentheses 9 squared, we get negative 27. So what does that mean? 4 days in, there's 48 sick people, and 9 days in, there's negative 27 sick people? That doesn't make sense. We have to remember that we're looking at rates of change. We're not just plugging in days and getting out the number of sick people. We're looking at a rate of change. It has 2 units. So to help interpret this correctly, when I have average change or instant change, I need to remember that for rates of change, they have 2 units. Let's remind ourselves of that by writing it on top, maybe starring it and highlighting it. It has 2 units. So if we're plugging in years and getting out dollars, we would say dollars per year. This one, we're plugging in days and getting out number of infected people. So we want to do the output over the input variable. So we're going to say number of people infected. But it's not just the number of people infected, it's the number of people infected per day. Same thing with this one. Number of people infected per day. So this is a rate of change. So at day 4, what we would say is on day 4, the number of people getting sick was what? Well, we got a positive 48. Remember, instantaneous change is slope at an instant. So if we have a positive slope, was the number of people getting sick increasing or decreasing? If it's positive 48, was increasing by 48 people per day. So it was going up on day 4. The amount of people getting sick was increasing by 48 people per day. On day 9, though, the number of people getting sick or people getting the virus was what? It's negative 27. So if you have a negative slope at that instant, is it increasing or decreasing? It was decreasing by 27 people per day. Notice we don't say decreasing by a negative 27 because a negative and a negative cancel and make it positive. So we just say decreasing. That accounts for the negative and 27 people per day. So on day 4, the number of people getting sick was increasing. It was going up by 48 people per day. But by day 9, maybe they came out with some sort of antidote or they were separating people or something like that. Something made it so that the number of people getting sick was decreasing by 27 people per day. Maybe the weather changed. Who knows? Something was in the air making this spread really fast on day 4 and then start slowing down by day 9, which is a good thing. So we want to remember with a word problem not to panic. When we plug into the original, if it says average change, we'll use slope. If it says change in an instant, we'll take the derivative and plug in. And we just want to remember that if we plug into average or instantaneous change, it has 2 units. And knowing those 2 units, it's always output over input, is going to help us with interpreting what we actually just found.